everybody! Welcome back to Fun Facts with Faith. Today we're continuing on the trend of facts I got from my friends. This is a suggestion from Colin, but funnily enough, it's actually about research that was done by my friend Rachel. 3D movies. These days they're practically a staple of the summer blockbuster season, at least when we have a summer blockbuster season, you know, when there's not an apocalypse on. But I remember going to see one of the Spy Kids movies, like in the very, very early days of 3D, where it was still those like flimsy cardboard glasses that had like one red lens and one blue lens. You can picture what I'm talking about, right? Okay, now like picture that, but on a cuttlefish. It's sort of an odd mental image. Why are we doing that? Well, we're doing it to study stereopsis. So stereopsis is the ability to perceive depth and 3D structure. In humans, this is achieved by the brain processing what is called binocular disparities. So basically, because your eyes are in two different positions in your head, when you look at something, you're actually receiving two slightly offset images, right? Each eye has a slightly different perspective, and those images are projected back onto the retina, and then your brain receives them. And so the differences in those two images, the offsets, are processed, and that is what gives you the sense of depth and distance. And you can simulate that by sort of deliberately presenting two different images separately to each eye, and then forcing your brain to combine them. And that is how the sort of red and blue form of 3D vision works. You project two slightly offset images in different colors. One is only visible to one eye and one to the other because of the way that the colored lens filters, and then you get the illusion of 3D. Cuttlefish, adorable little cephalopods that they are, have kind of weird eyes. But what makes them sort of special amongst cephalopods is that, unlike, say, octopus or squid, cuttlefish can swivel their eyes forward, like they can both look forward, which might mean that they can use stereopsis for depth perception. So how are we going to investigate this? Or, I mean, like, we're not doing anything. How is Rachel going to investigate this? So what she and the rest of the team did was Velcro tiny little 3D glasses to the cephalopod. I'm just picturing this. Like, can you imagine doing that? It's hilarious to me. Anyway, okay, so like super cool little patch of Velcro to the little cephalopod head, and then Velcro some 3D glasses on them, and then put them in their tank. And then what they did was projected some images of shrimp, like offset in two different colors, and they like made it look like they were at different distances from the tank. Cuttlefish launch their tentacles to catch their prey, and they do it from a specific distance. So you can tell if the cuttlefish is successfully perceiving the shrimp image to be at the distance that you've set it by whether or not they back up or move forward before they launch. And if they do that, that would indicate that they are using stereopsis because they're like correctly perceiving that the shrimp is like closer, or the shrimp image is closer to them or farther away. So they tried it, and that's exactly what happened. So yay, congrats, cuttlefish can see in 3D. This makes cuttlefish the second invertebrates to be shown to use stereopsis for depth perception, distance perception. The other would be praying mantises, although interestingly, like humans are able to perceive depth even when everything that they're looking at is still, but a praying mantis actually can only see depth when they're looking at something that's moving. So yeah, cuttlefish, very cute, also able to see in 3D. That's it for today. Come back tomorrow for another fun fact. Bye.